What is up everyone, and welcome to our course on Python Language Basics. My name is Nimish and I'll be guiding you through the next couple of hours in which we'll be becoming familiar with the programming language Python. Our learning goals will be, of course, to become familiar with the basics of programming in Python. We're not going to go into super high level stuff, but we'll get you up to speed with the components that you'll need to build Python programs. We'll explore the primary components that you'll see in just about every Python program to the point where you're familiar enough with them that you can replicate that and use them to perform just about any task using Python. We'll learn how to store and modify data using Python variables and operations. And we'll learn how to execute behaviors and implement logic through the use of functions and control flow. So what are you going to need to go into this course? Well, actually, pretty much nothing. We assume that you have no experience coding or with Python. So that means we'll be exploring the language itself and any general coding concepts from a complete beginner's perspective. It doesn't matter if this is your first time ever coding or just your first time using this language. You'll find these tutorials easy to follow along with and informative. The best part is you actually don't even need to download any software to follow along with these tutorials, as we'll be running everything in a browser. So let's end with a quick list of topics that we'll be covering. The first will be an intro to Python. This will be just a few slides explaining what makes this language so great. We'll then have an introduction to Replit. This is the online environment I mentioned that will allow us to write and run Python code right in the browser. We'll then explore variables and how to modify them using operations. We'll take a look at collections, which are variables that store multiple values. Then move on to control flow, which will allow us to implement logic in the code. Functions will allow us to hide away blocks of code and execute them in multiple parts around our program. And then finally, we'll go to object-oriented concepts, which will allow us to model complex entities with state and behavior. So that's it. I hope you guys are super excited about this course. I really love using Python. It's by far one of my favorite languages. I really enjoyed making these tutorials for you guys. So I hope you enjoy them too, and at the very least find them informative. Thanks for signing up, and we'll see you guys in the first section. Python is one of the world's most popular programming languages. Featuring a simple syntax that reads almost like plain English, it's the perfect language for learning how to code. Developers absolutely love Python, as it allows you to write complex, data-heavy tasks both simply and quickly. Large programs can easily incorporate effective code reuse, making them shorter, more efficient, and easier to maintain. Finally, Python boasts a number of quality libraries and frameworks, which make developing with Python even easier. In short, Python has all that it takes to meet your programming needs. So what can Python be used for? Because of its versatility, Python can be used for a huge range of applications across various industries. It's used by some of the world's biggest organizations, including Google, YouTube, Facebook, Instagram, Spotify, Netflix, and so many more. Python is even used by Industrial Light and Magic, the FX company behind Hollywood blockbusters like Star Wars, Jurassic Park, and Harry Potter, and a number of game studios including CPP Games, who created EVE Online, and Firaxis Games, who've released Civilization 4. It's also the language of choice for data scientists, machine learning, AI, and even computer vision. From self-driving cars to facial recognition, fingerprint matching, and other smart Internet of Things apps, Python truly is leading the charge when it comes to innovations in the tech world. With such a wide variety of applications, it's unsurprising that PyPL ranks Python as both the most popular and fastest growing programming language in the world. The popularity is also reflected in the job market. According to Indeed, Python is the most in-demand language in the US. It's also the third highest paying programming language, with an average salary of $120,000 a year. And Python developers can earn these high salaries with relatively low experience compared to other mainstream programming languages. Python is simple, flexible, and can open up an endless world of opportunities. Get started with Python now and see where it will take you. What's up everyone? Welcome to our tutorial on an intro to Python. In this tutorial, we're going to introduce what Python is, talk about where we use it, and also why we decided to cover this topic. We'll divide this into 3 subtopics. The first being, what is Python? This will just introduce what Python is and go over where we use it. Then we're going to introduce some of the main features of Python that distinguish it from other similar programming languages. And finally, we'll finish up here with why we should learn Python versus some other languages today. So for starters, what is Python? Well, Python, as I just mentioned, is a popular programming language. This means that we use Python to write code that dictates how programs and applications should run. Python's extremely flexible, and this allows it to be used in many areas of programming, including but not limited to data science, machine learning, desktop applications, so these will be programs and apps that run on your computer, web servers, and also game development. Recently, Python has even made its way into mobile programming as well. Let's go over some of the features of Python. Although they are many-fold, we'll just cover some of the major ones here. For starters, Python is dynamically typed. We'll get into exactly what this means in some of the upcoming tutorials, but for now, this means that variables can change their data types. So we could start off with a variable representing some sort of text data, and later in the program that can change to, let's say, numerical data. This makes Python extremely flexible and easy to use for beginners. Python also features minimalist syntax. The idea behind Python, as stated by Guido von Rossum, who invented the language, is that he wanted Python to seem as close to written or spoken English as possible. So this means replacing weird symbolic operators with words like and or, just to make the language more easily readable. Also, Python features object-oriented aspects. Again, we'll dive into exactly what this means in some upcoming tutorials, but for now, just know that this means it's really easy to model real-life entities with state and behavior using the Python language. So let's finish up with why we should learn Python today versus perhaps some other programming languages. For starters, Python is extremely popular. It is consistently ranked in the 10 top most used programming languages, so you know that there's going to be a ton of support, there will be a ton of jobs that require Python programming, and it just has a lot of usage out there. Python can be featured in a wide variety of applications. As we saw at the beginning, there's no one specific domain in which Python is used. We can apply Python code to pretty much any programming domain, so this makes it an extremely flexible and versatile language. Because of Python's dynamic typing system, this makes it really easy to learn. So whether you're brand new to programming or you already know how to program and you just want to learn a new language, Python is a really good starting point. And this kind of goes along with the beginner-friendly syntax. Again, it makes it easy to learn new programming concepts while you're learning language syntax, and if you're coming from other more rigid languages, you'll find this beginner-friendly syntax super easy to adjust to, and actually more intuitive than some other languages. Okay, so hopefully you guys are convinced how great Python is. It's definitely one of my favorite programming languages, and I hope soon it will be yours as well. So in the upcoming sections, we're going to introduce REPL, which will be our programming environment, and then we can jump right into Python language basics. So stay tuned for that. Thanks for watching, and see you guys in the next ones. Hello everyone, welcome to our tutorial on an intro to REPL.it. In this tutorial, we're going to introduce and explore the REPL.it system, which is a way to write and run code. We'll divide this into a couple of subtopics, the first being what is REPL.it. This will be a simple slide explaining what REPL.it is and go over why we're using this particular system. And then we'll turn right to REPL.it in a browser and we'll explore the interface. Once we're familiar with the interface, we'll run a really simple Python program. This way you can get used to writing code, running it, and seeing the output. all within REPL.it. Okay, so for starters, what is REPL.it? This is simply an online environment where you can write and run code. The best thing about using something like REPL.it is we can run it right in a browser. This means there's no need to install or download any cumbersome software and get set up with an environment that you may never use again. Repl.it recognizes over 45 different programming languages. This makes it an ideal tool for if you're brand new to a programming language and you just want to try something out. That makes it the perfect thing to use for our language basics sections coming up, as we just want to get familiar with Python syntax and various programming concepts. So no need to download anything to use this environment. Also, Repl.it allows users to save and share code with ease. Without using something like Repl.it, you may have to bundle, upload, and then perhaps email files or upload them to something like Google Drive and share them that way. This actually makes it really easy to do, and you can also connect systems like GitHub if you already have a GitHub account. So all in all, Repl.it is kind of the perfect tool for beginners when you're first starting out with a new programming language. So enough about talking about it, let's head on over to a browser and we'll explore the interface. Okay, so I've got a browser open here. This is Google Chrome, although it doesn't really matter which one you use. I'm just going to search for Repl.it. Okay, and this is what the home page looks like. So there's a few options here. You can log in if you already have an account, you can sign up to create a new account, or you can actually start coding without creating an account. I recommend at some point in time you do create an account. The benefits are manifold and it's free, totally easy to sign up. However, it's a bit of a process. You have to go over stuff like what's your favorite programming language, what kind of features you want to see, etc. So it can take a few minutes. If you want to go ahead and go through the sign up process, feel free to do so. Probably just pause this video, finish that, and then come back. Otherwise, you can click on Start Coding just to get started right away. I'm actually going to log into my account as I've already created one, and I'm going to show you what the interface looks like if you already have an account. Okay, so here I am in my specific home page. You can see my account name up here. You can see there's a panel on the left-hand side. Let's just zoom in a little bit, and we can go to the home page. This is kind of what it looks like. Gives you the option to create a new REPL in kind of my favorite languages here. It lets me take a look at some recently viewed and edited REPLs, connect GitHub easily, and there's a few other options down there. I can view the full list of my REPLs in here, although I don't have very many saved right now. You can chat someone and see notifications, and then there's a few other resources down at the bottom there. So if we want to create a new one, we could create a new one here, or just a new REPL up here. I'm actually just going to go ahead and click on this. Okay, and it gives me the option to choose one of these languages or just to import one. Now, because we'll be covering Python in the upcoming tutorials, I see no reason as to why not to start there. Let's select Python here. We can give this guy a name, although it kind of generates a weird one automatically. I'm going to call this something like Python Language Tutorials, as we're going to be using this specific REPL for the remainder of the Python language basics. So we'll go ahead and create that REPL. And you can see it appeared in my recently viewed REPLs, and it's taken me to this specific REPL. So we can think about REPL as being like a programming environment where we can create and use multiple files, we can view the specific files, and we can actually run them and produce output right away. It's not just a single run window. So if we want to create a new file, we can simply click on the add file up here. You can add a folder to create a more structured project. It starts me off with a main.py file, so for now we'll just be working in there. Also, you can link some sort of version control if you want to work collaboratively with other people. You can import other Python packages. There's the debugger mode for easy viewing and finding of errors in your code. You can also connect a database, and then there's just general settings as well. The four components we're really interested in are going to be the File Explorer. Again, for the most part, we'll be working in the one file, although we'll archive all of the old code in another file later on. The second thing is going to be the actual coding window. So this is going to be basically the contents of our main.py file. We'll write all of our Python code in here. The third thing that we want to see is the output screen. This is on the right-hand side, and every time we print something to the console, it's going to appear here. So this is going to be a really good way to check our outputs to see if, as we learn Python language basics, we really understand the concepts and we're getting the right answers. The fourth and final thing I want to point out here is the run button. Anytime you write any code that is runnable, you can click on this and then go ahead and produce the output. So to get started, we're going to just run a really simple Python program that will just make use of the print function. The print function looks like this: print, have the parentheses here, okay, and then we can just put whatever we want to print right within these parentheses. Now, there's some restrictions for now, although we'll kind of go over how we circumvent those in the future tutorials. For now, if you want to print something, simply put it between the double quotes or the single quotes. Other than that, you can print pretty much whatever you want. If I want to print the classic hello world, I can do so, okay, and as soon as I go to run this, because this is a runnable statement, you will see hello world printed to the console. Again, if you want to change this around, maybe I want to print my own name, okay, I can go ahead and run that, and you see that the contents have changed. Basically, it will print anything that you see within this window here, or within these parentheses. So if you've been following along up until this point, congratulations on writing and running your very first Python program. I know this isn't too interesting, but in the upcoming sections we'll be exploring different Python language basics, and that will help you to write and run more complex Python programs. For now, I just recommend trying out some different texts, maybe running a few print statements. You can actually run multiple in a row and it will print a new one every time. So go ahead and mess around with that a little bit, and when you're ready to move on, we'll start learning about Python language basics. So stay tuned, thanks for watching, and we'll see you guys in the next ones. What is up, everyone, and welcome to our tutorial on variables. Here we're going to introduce the concept of variables in Python, and we're going to see some real code examples of variables in use. We'll divide this into two major subtopics. The first being what are variables. This will just be a single slide quickly outlining what variables are and how we use them in code. And then we're going to turn to REPL.it and we'll write some code to explore some real examples of a couple different kinds of variables in Python. For starters, what are variables? Variables, from a programming standpoint, are simply how we store data in our code. At the end of the day, programs and applications are all about storing and manipulating data. So we need to keep track of this data as the program runs, and that's where we use variables. We can assign a value to a variable, and later on we can reassign that value as the program's state changes. Now, in some languages, there is a concept of constants, which are variables whose values cannot change once they've been assigned. Python doesn't really work with constants, so just know that every variable we create in Python can change its value at some point in time. Now, because there are going to be many different kinds of data that we need to keep track of as a program runs, variables are used to store different kinds of data, such as maybe numbers or texts or true or false values as simple data types, and things like collections like lists or objects as more complex types. We'll be exploring concepts like lists and objects in future tutorials. For now, we'll just focus on numbers, and in the next section, we'll focus on text and true or false variables. So now that we've had a brief intro into what variables are, let's turn to REPL.it and we'll see some variables in use in some real Python code. Okay, so here we are back in REPL.it. Again, this is my Python language tutorials. This is where we finished up with a simple print statement. We ran it and it just printed some output to the console here. So hopefully you had a bit of fun with that. We will be using print statements in pretty much every tutorial from here on out. So for now, I'm just going to get rid of it so we can start from a clean slate. Okay, so variables in Python. How do we create variables and assign values? Well, it's actually a very simple naming convention in Python. We simply assign a name to a variable, and we use what's called the assignment operator, or the single equal sign, to assign some sort of value to this variable. So in our case, this statement doesn't really mean anything right now, but it demonstrates a concept of creating a variable with this name and assigning this value to it. There's no need to introduce special keywords like variable or let or anything like that in Python. Simply need a name and a value. Also, in some languages, you might see something like this where it needs a type. That's totally not necessary in Python. The type of the variable, which represents a kind of data that the variable can hold, is automatically interpreted by the value we assign. Remember, variable types can change over time, which means variables can hold different kinds of data, but more on that a little bit later. For now, let's just focus on numbers. So this just really represents a template. I don't want to actually run this code, so I'm simply going to comment it out. Just so you know, what I did there was I changed this line of code into a comment. So a comment is essentially just text within our program that's there for us to read. So we can use this to convey messages to future programmers or to ourselves, maybe make to-dos. So if a function needs some sort of implementation later on, we can add in some sort of a comment explaining how it works or something like that. Or we can just use this to comment out code that we no longer want to run. So for example, if I do this and I try to run something, this is not legitimate code, so it's going to cause an error. However, if I comment this out with the pound sign, then this code is essentially not going to run. It's just there for our reading. Okay, so back to numbers. Let's think about where we might use numbers in code. Well, how about if we're developing a game and we have some sort of a positional variable, maybe the X position of a player or some sort of character. So we might do something like this. X position, okay, so that's the name of our variable, and then assign it a value, maybe 10 or something like this. Okay. So there's a couple of things to note here. First of all, we've created a variable called xposition, so this is the name, and then we've assigned it the value of 10. So this is clearly some sort of a numerical variable. Also note the use of the underscore between x and position. When we're creating variables, typically we divide the words of the variable up by underscores. In some languages you'll see something like this, camel case instead, but in Python this is the typical naming convention, although technically it doesn't really matter that much. Okay, so we have our variable here. If we want to actually print out the value, what we can do is we can run a print function and we can actually just pass in the variable. So in this case, there's no need to wrap this variable name in the quotations like this, okay? I'll explain what that means a bit later on, but if we want to print out the actual value of a variable, we simply pass that variable name into the print function. And if we run this, this will print 10 to the console, because when we run this print function, it gets the variable here, which gets the value assigned, and in that case, that is going to be 10. Similarly, we can reassign a value to this. So let's say the x position changed somehow. Maybe the user moved forward 5 steps. So the position is now 15. Well, we've reassigned a value to it, so if we go to print out the new value of our x position, we should see first 10 because we're running this statement, and at this point in time equals 10, and then at the second point in time it equals 15, so when we print out the new value of the position, we get 15 printed there. So from now onwards in our program, the x position takes on the value of 15 because that's the latest value assigned to it. Now you'll note that this is a whole number. So that means that this type of variable is an integer. So integers represent all whole numbers. They could be positive or negative. Sometimes, however, we will need to access decimal numbers. For example, if we created a variable called pi. So pi is the first 3 digits, 3.14. This needs to be a decimal number, and so because it is a decimal number, we use the float type of variable. So we use integers for whole numbers and floats represent decimal numbers in Python. We could just as easily have made this a float variable by adding a decimal place and a 0.0 to it if we really wanted. However, for our purposes, it doesn't matter too much. So this is another numerical type, but it just represents decimal numbers. Otherwise, it works in exactly the same way. It doesn't make sense, but if we wanted to reassign this to 3.13, for example, that would be totally fine. Or if we want to have a bit more precision, 3.14159, then we can do that, and that's totally fine as well. Just like before, we can print this out if we want. We can print out pi, and it's going to, again, run everything in order. So we should see the first 2 numbers printed out, and then finally our pi as well. Now, a couple of things to note here. First of all, because variable types in Python can change, we can actually do something like this. X position is equal to 15.0, Okay, and in that case, X position changes very, very slightly. Although the actual value stored is still 15, I mean 15.0 is the same as 15, it has now changed its type because we're changing it to a decimal number. So remember, integers are whole numbers, floats are decimal numbers. So we've changed the type of X position from a whole number to a decimal number, so from an integer to a float. And in Python, that's totally valid. In some other languages, not so much. If we're ever unsure about the type of a variable, for example, we see a number, we don't know whether it's an integer or a float, what we can do is actually print out the type of that variable. And we don't just have to print out the type, we could just get the type of the variable. So for example, let's say the type of the variable of X position, we want to know what that is. Okay, we could just assign this to a variable if we want. So we can say X position type is equal to this, and then we can print out X position type, or we can actually just stick this right in the print function. For convenience sake, I'm just going to stick it right in the print function like this. If we then run this, we should see that we're getting the class float being printed out. And that's what we would expect because, again, we changed this whole number or an integer to a float as soon as we added the decimal place onto it. Similarly, you could do this if we didn't make this change. For example, if we just kept it at 15 and ran this, you would see that it is the class integer. All right, so that is pretty much all we want to cover here. We introduced the concept of variables, comments, integers, and floats. Remember, integers are whole numbers, floats are decimal numbers. We also worked on printing out variables and printing the type of variables. So give this some play around. Maybe create some more integer and float variables, work on assigning and reassigning them, work on printing them and printing out the types. And when you're ready to move on, we'll work on text and true or false variables. So thanks for watching, and we'll see you guys in the next one. Hello everyone and welcome back. This is part 2 of our variables tutorial. In the previous section we covered integers and floats, the numerical types, and in this section we're going to cover booleans, which are true or false variables, and strings, which are text variables. So without further ado, let's head on over to REPL and get started. Okay, in the previous section, this is the code that we wrote. Hopefully you played around with it a bit more, maybe printed out the type of our float variables to see that versus the type of integers, created some more integers and floats, printed them out, worked on assigning and reassigning, and hopefully you're comfortable with all of that. By the way, I put all of the code that we wrote, which was in main.py, into a file called archive.py, and I'm going to do this at the end of each section. That way we can start from a clean slate in main.py, and we're not kind of rerunning all that old code. Okay, so let's start with booleans because they are the simplest of the 4 variable types basically. So booleans are either true or false values, so that means they can only take on one of 2 possible values. This makes them very, very useful for situations in code where we essentially want that behavior. A variable can only have one of 2 states. So we might use this for something like, is a light on or off, is a door open or closed, or perhaps is a game over or is it still running. We're going to try to relate all these examples back to game developments in some way so that when we move to the game development portion of the tutorial series, then we can actually just copy and paste a lot of this code over. So let's create a boolean called isGameOver, and this will either take on true or false based on whether the game is still running or perhaps we've unfortunately encountered some situation where the game is over. So we either assign the value of true if the game is indeed over, or false if the game is not. Okay, so note the capitalization of each one, so perhaps it's not over at first and then something happens that makes the game end. Okay, note again the capitalization of the F and the T. In most other languages I've seen it's either true or false with the lowercase like this, but Python really wants to distinguish the two. Alright, so it's only ever one of these 2 possible states. Otherwise this works in pretty much exactly the same way. We can print is game over, just like before. If we go to run this, you'll see the value of true being printed out there. If you want the type of is game over, we can do something like this, type of is game over, and this will print out the class bool. Just like before, we got ints for integers and float for floats. So pretty easy to use variable. Now, interestingly enough, again, variables can change their type. So not only can we go from an integer to a float and vice versa, we can actually, weirdly enough, go from an integer to a Boolean, or a float to a Boolean, or again, vice versa. So let's say, for example, I wanted is game over to be equal to some sort of a number. Maybe I want this to be 1. Okay. In a lot of other languages, this isn't allowed, and in our context, it doesn't really make too much sense. But just note that this is actually a perfectly valid operation in Python. If we were to then print out the value after changing it and the type, we would see that the value has changed to 1, and the class has now become an integer. Okay, so this is why it's very important to check the type of your variables before you go to use them if you're ever unsure. If you ever receive a variable and you don't really know what type it is, then definitely check the type of it to make sure that you're not going to run into any errors. This could cause a lot of problems if you're expecting a true or false value and you get maybe a 1 or a decimal number or something like that. Okay, so it's Booleans in a nutshell, either true or false values, fairly straightforward. We'll later on see that Booleans can also take on the value of comparison operations, such as 5 greater than 2, but more on that when it comes to operations. Okay, so the next type of variable I want to cover is going to be string variables. Now, strings are by far the most complex out of the 4 types: ints, floats, bools, and strings. And this is because strings are actually lists or arrays of characters. So we treat them as if they're single value variables like a Boolean or an integer or a float, but in actuality they are lists of characters. So a string is used to represent any kind of text data and is anything between the double quotes or the single quotes. So this could be used to represent names, it could be used to represent text or messages or anything like that, basically anything text related. So let's say we want to create a string of a character or a player name, perhaps. I'm just going to create something called name. I'm going to assign it my own name. Okay, so it doesn't matter whether, again, it's between the double quotes, or we could do the single quote like this, and that is totally valid. Both of these values are exactly the same. Just make sure you're not mixing them up and doing one single, one double, or vice versa. Okay. Now we can even use strings to represent a text form of something like a Boolean or a number. For example, let's say I wanted the text of is game over. I could do something like this: is game over text is equal to, and then I could say something like false. Now note that this is not the same as this, okay? Because this is a Boolean type, either true or false. This is the text representation of that. So this is actually a list of 5 different characters. This is really just a true or false value, okay? So note they are not the same. Similarly, if I had a number, so let's say I had age as a number, okay? And I set this equal to, or rather as a string, okay, and I set this equal to, let's say, 5 or something. This is not the equivalent of the value 5, okay? Otherwise, we can print out strings or print out the types of strings just like before. So for example, if I copied and pasted this, and I'm just going to replace that with name and name, so I'm printing out the value and the type of name, and go ahead and run that, and you can see I'm printing out my value, and I'm also printing out the class, in this case, string. Now, there's lots of other operations that come with strings that don't come with Booleans, integers, or floats. We're going to explore some of those other operations when it comes to collection types like lists or arrays, because essentially, again, strings are arrays. More on that a little bit later. We'll explore one specific operation I find extremely useful, however, and that is if we want to combine, let's say, a string with some sort of numerical data. Okay, so I have age as a string here, but let's say I want the actual numerical value of age. So I might have age is equal to maybe something a bit more realistic. I'll put my own for now. Okay, so essentially what I want is something that looks like this. I want my name, and then I want the age as well. So let's say something like this. Okay. I can use the string formatting function to achieve this by passing in this value into some sort of a string. So let's say I have something like this: name and age is equal to this. I have my name, but I don't necessarily want to just hard code in my age. Maybe this is some sort of a variable that I'm fetching from maybe a database or something like that. So what I can actually do is put a placeholder for my name. Okay, so essentially by using these curly braces here, I'm saying that at some point in time there will be a value assigned to this, so that we'll replace these with whatever value we assign. So let's say I want to assign my age. What I can actually do is just say this dot format, okay, and then I can put in my age here. So I put in the age variable. Alternatively, I can actually just dump 27 right in there as well. So the way that this works is it has the regular string up until this point. It sees the curly bracket, says, okay, I'm expecting some sort of a value. So it needs one value, or one variable rather, for every one of these that we pass in. If I had two of them, I'd need multiple variables. Okay? For now, we just have the one, so we just need the one curly brace, dot format, and then the variable that we want to pass in. And now look at what happens when I print out name and age. Okay, I go to run this, and I'm getting my name, and then the actual value of the variable stuck right in there as well. Okay, so this is a very, very useful trick if we are passing in values for variables that we don't necessarily know, because of course we can't always hard code everything. That's really what variables are all about, is storing data so that we can use it in other parts of the program such as this. Okay, so that is the basics of strings and booleans. Again, we'll go more into some special string functionality when we cover topics such as collection types. For now, what I'd recommend you do is practice using these booleans or true or false values and some strings as text values. Remember, variable types can change, so we can start off with a string variable and then assign maybe an integer type to it, and that's totally valid. So perhaps try creating some strings, reassigning and assigning the values, printing out the names and types. Definitely practice a bit with this formatting. You can pass in any type you want, be it booleans or integers or floats, and once you're ready to move on, we'll work on operators. Okay, so stay tuned for that. Thanks for watching, and see you guys in the next section. Hello everyone, welcome to our tutorial on operators. By this point, we should be fairly comfortable creating variables and assigning and reassigning values. In this section and the next, we're going to explore some operators that will help us to manipulate those values programmatically. We'll divide this into two subtopics, the first being what are operators. This will just be a single slide briefly outlining what operators are from a programming standpoint. And then we're going to go over some examples of operators in use in REPL.it. Now there's quite a lot of operators to cover here, so we'll need a couple of different tutorials for them. In this section, we're going to focus on arithmetic operators, and in the next section, we'll focus more on logical and conditional operators. Of course, those words will take on more meaning as we go. So what are operators from a programming standpoint? Well, these are simply symbols which perform specific mathematical, relational, or logical operations. Now, these can be used to manipulate variable values in some way by maybe adding some value to a variable, subtracting a value, etc. Or these can be used to perhaps compare two values and return a true or false result based on the values they contain. So the basic ones that we'll cover here will be the addition, subtraction, multiplication, division, and some other arithmetic operators. We'll save the more relational and logical operations for the next section. Okay, so enough talking. Let's get on over to REPL.it, where we'll write some actual code and see these operators in action. Okay, so back to REPL.it. This is main.py. I've cleared out everything and stuck it into archive.py just like before. So we've got our integers and floats code and our booleans and strings code. I hope you guys are pretty comfortable using the integers, floats, booleans, and strings. Again, we're going to go over some more special string functionality in the upcoming sections. But for now, as long as you can assign values and reassign values, maybe print out the value and the type, that's good enough. Okay, so back to main.py, where we'll put those variables to use. Now, in this section, like I said, we'll be studying mostly the arithmetic operators. So what I mean by this are going to be the addition, subtraction, multiplication, division. There's also the modulo or modulus operator, floor division, and the exponentiation operator. We'll also take a look at the assignment operator and some combination operators, although we've actually been using the assignment operator already. Okay, so In order to demonstrate these, we'll need to create some variables for us to use. So I'm going to create an x position variable. Okay, and I'm just going to start off with maybe the value of 10. Okay, so let's say we're developing some sort of a game in which we can move around. So we might want some sort of functionality that will increase or decrease the position, regardless of what value it is. If we wanted to move forwards, perhaps we would change this to 11, and it would be easy enough to do this and set that to 11. However, if we just wanted to move forwards by one step, we can't guarantee that the x position will always be 10 to hard code it to 11. What if unknowingly the x position was 5? Well, now that's an increase of 6 steps instead of just 1. So what we can do is we can just get the current value of x position, add 1 to it, and that way we're guaranteeing that we're only ever advancing by one step at a time. So what we could do is something like this. I'm actually just going to comment that out. Okay, what we could do is something like forward is equal to our x position plus 1. Okay, so a couple things. First of all, we are again using the assignment operator that just takes a variable on the left and assigns a value on the right. It doesn't matter what kind of complex expression we're using, it just gets the result of this and assigns it. So we've already seen that one. However, we're introducing now the addition operator. So much like all of these, it takes two values, one on the left and one on the right. It performs the operations, this could be adding, subtracting, multiplying, dividing, etc., and then returns a result, which in this case we're storing in the variable forward. So forward now contains the value of x position, 10, plus 1, so 11. Okay, and in fact, to verify that, we'll just print out. Okay, so forward, we print that out, and we get the value of 11. Similarly, if we wanted to move backwards, we could do backward is equal to x position minus 1. Okay, so what do we think the value of backward would be? Let's go ahead and run it and find out. So it's 9. Hopefully this doesn't confuse you guys, because instead of doing 11 minus 1, we're actually still doing 10 minus 1. The value of x position has not changed throughout all of this. We're just guessing the value stored, adding 1 to it, and storing the results here. Here we're just guessing again the value that was assigned to it, subtracting 1, and then storing that in backward. Okay, so the addition, the subtraction, and all of these don't actually change the original variable value, they just return a new result. Now, we can use a combination of variables and literal values like this. We could also use two variables, we can use two literal values. It doesn't really matter, there's no difference there. Okay. Now, the other operators that you might not have seen before are the modulus operator, the floor division, and the exponentiation operator. So the modulus operator will perform a division and return a remainder. For example, let's say I wanted to do, let's just call this remainder is equal to 5 modulus 2. Okay, so again, two literal values, that is totally fine. If I wanted to print out remainder, what this does is it performs a division, so 5 divided by 2 will be 2, with a remainder of 1. Okay, so we could actually just do 5 divided by 2. Yeah, that would give us 2.5, but if we wanted to keep it to whole numbers and just wanted the remainder, we could do this, and you can see that it prints out the remainder of 1. Floor division, on the other hand, does pretty much the same thing, but reversed. So instead of returning the remainder, it will perform the division and discard the remainder. So by that logic, I can do something like this. Floor division is equal to 5 floor 2. Okay, and I'm just going to go ahead and print out the floor division. Okay, so this is now going to give me 2. Okay, because again, 5 divided by 2 is going to be 2 with a remainder of 1. It just discards the remainder and returns the result. The exponentiation operator is just used to raise a number to a power. So for example, let's say I want 5 squared, and I'm going to set this equal to 5 with the exponentiation operator of 2. Okay, so then I'll print out 5 squared. And I think this is just disconnected and is reconnecting. So I'll just pause this until it's finished. Okay, it looks like we're back in business. We can go ahead and run this, and in this case we get 25 because that is 5 squared. All right, so in addition, we can combine any of these with the assignment operator to do something like this. So let's say I wanted my new x position to be its current value plus 1. So right now, x position. Okay, I'm going to go ahead and actually just print out the x position just to show you guys. We'll do this. Okay, we get 10. All right. Let's say I wanted to add 1 to it and store the results back in here. So I could do something like this is equal to x position plus 1. Now this is going to take its current value 10, add 1 to it 11, and then it will store it back into x position. So if I run this, you'll see that its new value is 11. So from now onwards, x position has the value of 11. However, I can actually short form this to be something like this. Let's just comment this out. I could do x position plus equals 1. So this is combining the addition and the equal of the assignment operator. So this is saying x position is equal to its current value plus 1. Okay, and we'll get exactly the same results, 11. So you can apply that same logic to any of these. You can do a subtraction equals, multiplication equals, division equals, and so on and so forth. Now, the final thing that I want to cover here briefly is strings. We can also, weirdly enough, use the addition operator with strings to concatenate them together. So for example, let's say I have first name, okay, and then I'm going to put a space there, you'll see why, last name. Okay, and I want my full name, or maybe I'll just print it out actually. I can do something like this, first name plus last name. Okay, so what this will do is it will take the value of first name and it will stick the last name onto the end of it. So I can go ahead and run that, and you can see that I get that combined string. You can also apply the same logic with this plus equals to the strings, but you can't take an integer or a number and combine it with a string. That just doesn't really make much sense. All right, so that is pretty much it for now. We covered the arithmetic and the assignment operators. Definitely give this some practice. Try another example of each of these operators in action along with the assignment arithmetic operator combinations. And try combining different values of numbers and booleans and strings to see what you are and aren't allowed to do. All right, we'll go over more operators in the next section, so stay tuned. Thanks for watching, and we'll see you guys there. What's up everyone, and welcome to part 2 of our operators tutorial. In the previous section, we covered the arithmetic and assignment operators. Now we're going to move on to the conditional and logical operators. So hopefully you got enough practice and you're ready for this section. Let's head on over to Replit and get started. Okay, so previously, again, we covered the arithmetic assignment. We saw that they are used to perform typically arithmetic operations on numbers, although we saw we can also combine strings. Hopefully you had a bit of practice with these, working with numbers, booleans, and strings to see what you are and aren't allowed to do in Python. There are some weird little tips and tricks that you can apply with these operators. However, just note that every single arithmetic or assignment operator is going to return a result based on what we feed into it. So for example, it might return a number if we're adding or subtracting numbers. It might return a string if we're combining strings. The difference between this and the conditional and logical operators is that the conditional and logical operators will always return true or false based on some sort of a comparison. Okay, so these consist of our greater than or equal to, less than or equal to, is equal to, and not equal to. These are the conditional operators. For the logical ones, we also have the not, or, and the and. So again, always compare two values and return true or false. So in order to demonstrate these, we're going to simulate a scenario where we have an x position. Okay, we'll maybe set this to 1 or something. We have an end position, maybe set this to 10, and we want to check to see if we're at the end. Okay, so what we can do is something like is at end. There's going to be a variable that returns true or false based on whether we've reached the end. And we could assign this equal to our x position is equal to our end position. So this will fetch the value here, 1, and it will say, is it equal to the end position 10? 1 and 10 are not equal, so this is going to return false and store it in is at end. So we can print that out to confirm. Okay, give this a run and you'll see false being printed. If we change this value to 10 and reran it, you would see true being printed. Now, the other operators work in pretty much exactly the same way. So for example, let's say we want to test to see if we're at the halfway point. We could say is at halfway is equal to x position greater than or equal to 5. Okay, so if we go ahead and print out is at halfway, okay, again, we're going to get false there because 1 is not greater than or equal to 5. Now, interestingly enough, we can model complex expressions on either side of these logical or these comparison operators. So for example, let's say I don't necessarily know what my end position is, but the halfway point is always going to be exactly half of the end position. So I don't know that it's 5. What I could do is say end position divided by 2. Okay, so what this will do, the order in which this will work, is it will get my x position, 1. It will get my end position divided by 2, so this will be 10 divided by 2 or 5, and then it will perform the comparison. Is 1 greater than or equal to my end position divided by 2, 5, still going to return false. So if I rerun this, I should still see false being printed there. Okay. So other than that, the comparisons work in exactly the same way. This will return true if values are not equal to each other. Okay, and this returns true if they are. So let's move on to the logical operators, starting with the not operator. This one's pretty simple. It's just used to reverse a Boolean value. So for example, if I wanted to see if I'm at the end, okay, but I want to reverse that. So if it's true, I want to change it to false. If it's false, I want to change it to true. I could manually assign it, but perhaps I don't necessarily know what the value is. So perhaps I just want to print out the reverse of that. I could just do something like is at end, but I want the opposite, so I want not is at the end. And if I go to run this, I get the value of true because is at end is false, and the opposite of false is true. By the way, I just put this in the print statement for convenience sake. I could totally assign this to a variable and then print that out. So let's say not is at end is equal to this. Okay, and then I could put that in there. It's really exactly the same logic. Now, where things get a little bit more complex is the introduction of the or and the and operators. So if you're coming from other languages, you might have seen them as this and the double ampersands, okay? So essentially what they're used for is to perform additional Boolean checks. Let's say I'm now introducing a point system, so the game is over when I'm at the end position and I have enough points, maybe points equal to 10 or something. So I can create a score variable, maybe set this equal to 10. My isGameOver variable is only going to be equal to true when my points is greater than or equal to 10, so score greater than or equal to 10, but I want the additional case that I'm also at the end position, so I need both to be true. So for that I can use the AND operator, and then I can say something like is at end. Okay, so there's a couple things to unpack here. First of all is this guy here. So is at end is like saying is at end is equal to true. Okay, so it's just a short form when we're working with Booleans. If we just call the Boolean name like this, that's saying, is this equal to true? Okay, just so you know, again, it's the exact same as doing this. Okay, so the second thing to unpack is the use, of course, the AND operator. So this will return true for the whole statement if this is true and this is true. So if either one of them is false or both of them are false, the whole thing returns false. So let's say my score is only equal to 9. And I go and run this, and oh, actually I should print out is game over. Okay, you can see false here because one of these conditions is false, therefore the whole thing becomes false. However, if both conditions are true, I get, oh, that's still false because we're not at the end. Let's say my x position is now 10. Go ahead and run this, and now you can see that I get the value of true being printed. On the other hand, the OR operator is used to basically do a similar sort of thing. It needs both, or rather it tests both conditions, but it only needs one of them to be true to return true overall. So for example, let's say I replace the AND operator with this. I'm actually going to copy this and just comment it out so that we have that code there as an archive. Okay, so let's say my score is 9, but I am at the end. So my end position is 10, that's good. So this will return true, but my score greater than or equal to 10 is going to return false, okay? Because 9 is not greater than or equal to 10. However, if I run this, this is the AND operator. If I replace this with the OR operator, then I still get the value of true because at least one of these conditions is true. If both of them are true, that's totally fine. I also get true printed out there. Okay, but if both of them are false, then I get false overall. All right, so that's pretty much all there is to it. I'm just going to change that back to 9. We covered the conditional and the logical operators. Again, all of these will always return a true or false result as long as the comparison is valid. We can also use these, by the way, to compare string values as well. It wouldn't make much sense to compare maybe a string to a number value, but you can compare strings to other strings, equal, not equal, even the greater than and less than. You can definitely test those out as well. Now, one final thing I wanted to point out to all of you is that, if you haven't noticed, every single new statement is on a new line, okay? So this is the typical convention when it comes to coding, although you can put multiple statements on one line when necessary. For example, if I have a semicolon, I can put another statement there, okay, and that is valid. What I can't do is do this. Okay, you can see immediately it gives me an error. Typically, we'll do kind of one statement per line, but if you really want multiple statements on one line, just separate them with a semicolon. Okay, otherwise that is it for now. In the next section, we're going to be covering the collection types or introducing them. So definitely practice this stuff. Make sure you're comfortable using each of these operators. Give each one a try, as well as the logical operators. Again, test out combinations of numbers, strings, booleans to see which ones can work with each other and what kind of restrictions you face. Once you're comfortable with all of this stuff, we can move on to collections. So thanks for watching. See you guys in the next one. What's up everyone, welcome to our tutorial on collections. Over the next few sections we'll be studying different kinds of collections available in Python, and of course going over some code examples of each in repl.it. We'll divide this section into two subtopics, the first being what are collections. This will be just a couple of slides outlining what collections are and going over the three main types we'll be studying. And then of course we'll turn to repl.it where we'll focus on just one of those types and go over some code examples. So for starters, what are collections? Well, up until this point, we've only ever really stored one value in one variable. And although that can change over time, it still only holds one value at a time. Well, collections allow us to store multiple values inside of a single variable for easy access and transportation throughout the code. We can access and modify individual values within a collection based on either the position in a list or a tuple, or the key in a dictionary. We'll explain exactly what we mean by that in the upcoming sections. We're going to study three major collection types found in Python. The first will be lists. These store their values based on position. So we access and modify elements within a list based entirely on their index or their position in that list. The second type is tuples. These act very similar to lists in that they store elements based on their position, but unlike lists, they cannot be modified, which means we cannot insert, add, or delete elements. The final type we'll study will be dictionaries. Unlike lists or tuples, the position of the elements really doesn't matter. Dictionaries that store their values based on keys, so in order to access or modify a value, we need to know its key. Alright, so these are the three types that we'll be taking a look at. You could arguably say ranges are collection types, but we may cover those in a later topic. For now, we'll focus entirely on lists. So let's head on over to repl.it and get started. Alright, so in the previous section we covered some of the conditional or comparison and logical operators. Those I stuck into the archive file, so they're here for our reference. Hopefully again you're comfortable with everything moving forwards. Make sure that you have all that down so that we can focus on lists. Now a list in Python starts like a regular variable, and don't worry about the disconnect, it will reconnect soon. it starts with the name of the list, the assignment operator, and then instead of a single value such as 4 or some kind of text, okay, it will store its values inside of these square brackets. This allows us to place as many values as we want, and they can be of all different types. For example, I could do 5, I could have a true value, I could have some sort of string. It doesn't matter what I put inside of this list. As long as they're between the square brackets here and separated by commas, I can put whatever I want in here. In fact, lists can be empty, have nothing in them at all, and that's still totally valid. The benefit of this is that if I ever need all of these values at once, I can simply access the entire list and I don't have to create a separate variable for each of these items. So take, for example, if I have a list of enemy positions. Realistically, I'd probably put these enemies in their own objects, but that's something for a different topic. For now, let's just pretend we have a list of enemies and they have various positions. So I might create an array called enemy positions, okay, or rather a list. Okay, and I'm just going to put some values in this. So I think we'll focus just on integers for convenience sake. Maybe I have enemies at positions 5, 10, and 15. Okay, so just like another variable, in fact, a list is a variable. It's just of the type list of whatever is inside of it. So like a regular variable, I can change its value. So I could do, for example, enemy positions is equal to 5, 10, 15, and 20. That's totally valid. You'll see that if I print out the enemy positions, let's just get rid of that, I get to print all of my elements here. So it's nice that it prints all of the elements separated by commas inside of a list exactly as it would appear in our actual code file here. Now, I don't necessarily want all of my elements at once. Sometimes I want to access just a single element. So for that, I can use positional or indexing values. Indexing is zero-based, meaning that this is at index 0, 1, 2, and 3, rather than the traditional 1, 2, 3, and 4. Okay? So let's say I want my very first element, and I'm just going to print it out. So I call upon my list, enemy positions. In the square brackets beside the name of the list, I put the index I want, in this case index 0, because I want the very first element, and that's it. Go ahead and run that, and you can see that I have fetched and printed my first element. Similarly, I could do 1, 2, or 3, but as soon as I try to access an index that doesn't exist, such as 4, I get an error, okay? And it says that the list index is out of range. Lucky for us, there's an easy way to check the length of a list to make sure that we don't go out of range. We can do that with the len operator. So if I do the len of my enemy positions, this will return me the number of elements in this list. So if I just want to print that out, I can do so. Let's just do 3 there. Okay, and this will print out my length of 4. Similarly, I can use these square brackets and an index to change an element. So let's say I want to change this 5 to a 6. What I could do is I could say my enemy positions at the index of 0, because that's my very first element, is equal to some new value. So I could do something like this is equal to 6, and if I print out my enemy positions, you'll see that the entire list has changed to accommodate that new value there. So that's going to be 6. Similarly, I can get an entire range of values by using the range operator inside of these square brackets. So let's say I want the first 2 elements. What I would do is I would get my enemy positions, okay, and rather than adding a single value inside of the square brackets, I add 2 values separated with a colon. The first being the start index, so in this case 0, and the second being the index after the element that we want. So let's say I want index 0 and 1. I would actually put 2 as the upper bound here. Okay, this does not include this one, it stops at this index. So again, if I go to print this out, you will see that I have printed my first 2 elements here. Now, lists come with a bunch of functions that help us to either fetch properties or modify them in some way. We're just going to really quickly cover a few of the major ones you will probably find yourselves using very often. The first is the append function, which sticks an element onto the end of a list. We just specify the list name, dot, and then the function, in this case append, and then add in an element. So let's say I wanted to add in 25 and print out my enemy positions. Okay, you'll see that I will have added 25 onto the end. Similarly, I can insert an item at a specific index. So rather than the append, I'll call the .insert function. I need to add an index. Maybe I want to insert it at index 1, and I want to insert the value of 9. Okay, if I print out my enemy positions, you'll see that 9 has been inserted there. I can also remove a specific value by calling upon my enemy positions.remove and then putting in the value I want. So let's say I want the 6 out of here. I can remove a 6, and if I print my enemy positions, you'll see that the 6 is gone from my list. Alternatively, if I want to delete based on position, I can call upon the delete function, or the del for short, and then I'll put in my enemy positions, at a specific index. So let's say I want to delete what is at index 2. Okay, then if I go to print out my enemy positions here again, you'll see that I've removed whatever element was at index 2, and for each of these operations, the entire list adjusts itself to accommodate the new elements or the deleted elements. Alright, so I think that is pretty much all we wanted to cover here. Like I said, there are plenty more functions, but these are probably the ones that we'll find ourselves using the most often. So what I recommend you do is definitely give these lists a practice. I know we only worked with integers, but like I said, we can put in any data type that we want within a list, including multiple data types at once. Try working with range operators, seeing if things go out of bounds or not. Work with these functions, the append, insert, remove, and delete functions. If any other functions that we really need come up in the future, we will absolutely introduce them at that time. Otherwise, once you're done playing around with lists and ready to move on to the next section, we'll start learning about tuples. So, thanks for watching, and we'll see you guys in that next one. What's up everyone? Welcome to part 2 of our collections tutorial. In the previous section, we introduced lists. We talked about how to create them, how to fetch elements or properties from them, and how to modify them in various ways. In this section, we're going to be doing pretty much the same thing, but focused entirely on tuples, the next collection type. So let's head on over to REPL and get started. Okay, as per usual, I've put all the old code in archive.py. Make sure that you're comfortable with all of this content that we covered previously, and hopefully you guys practiced on your own, creating some more lists, adding elements, removing elements, fetching, modifying, etc., and you're ready to move on to tuples. Now, if you're comfortable with lists, you should be fine with tuples, because tuples are just simplified forms of lists. We set them up pretty similarly, but the big difference is instead of the square brackets, we use the round parentheses. So an example of this might be something like a high score, okay? And in this case, I only need a few elements, and it doesn't really need to change. I don't need to change those individual elements necessarily. So I'm going to set up a tuple with these round parentheses, and I'm going to put a couple of values. Maybe a high score consists of a name and the actual score itself. Maybe I've got 120 points. So this is somewhat similar to a list in that we have multiple elements attached to, or multiple values rather, attached to a single variable. They're also separated with commas, and the general assignment looks very similar. The big difference is that we're using again the parentheses instead of the square brackets, and also this is an immutable tuple rather than a mutable list. So immutable just means it cannot change. Now, that's not technically true. We can change the entire tuple by reassigning it to reassigning a new value to this variable. What we cannot do is change the individual elements within the tuple. So we could do something like this. I'm actually just going to print out my tuple for your guys' reference. Okay, so this is what it looks like when it's printed out. Okay, so what we can do is something like this. High score is equal to a brand new tuple. Maybe someone came along and smashed my record, could be Holly, and she got 150 points. Okay, if I print out my new high score, that is a totally valid operation. What I cannot do is then say something like high score at the index of 0 is equal to some other name. Just going to put in some garbage string here. Okay, that is not allowed because tuple does not support item reassignment. I'm just going to comment that out. We can't change individual elements, but we can certainly fetch them. So for example, if I wanted just the name, I could do something like name is equal to high score of 0, and I could print that name out. That's totally fine to do. okay, as we can access anything we want in a tuple, providing of course that the index exists. So because tuples are immutable, it stands to reason that we cannot perform a lot of these list operations either. For example, the append, insert, remove, and delete operations all modify the list in some way. We can't perform any of those modification operations on a tuple. We can, however, do stuff like get the length of a tuple by using the len operator. So it's similar to a list, or even a string as we'll see in a minute. We can get the length of the high score and we can print that out, and that's totally fine. So in this case we get 2. Okay. And there's also another interesting operator, that is the in operator. In some languages you'll often see this as contains, but it's basically the same thing. So the in operator is used to determine if an element on the left is in the collection on the right. So for example, let's say I want to determine whether I'm still the high score owner. I want to see if Nimish is still in my high score. Okay, so this is going to return me true or false. True if Nimish is in the high score somewhere, and false if not. So I'm just going to go ahead and print this out. And you'll see that that's false, because of course my high score no longer contains that. If it was something that's in there, Holly, then that should be true. Alright? Now again, we can still apply the same operation to lists, that's totally fine. I just figured, seeing as we're pretty much done with tuples, that's really all there is to talk about, we may as well introduce a new function here. So, like I said, we're just about done with tuples. Again, they're a very simplified form of lists. The big benefit is that they are immutable, and I know that might sound weird to have something that's more restrictive than a list, but a lot of times we just don't need that extra heavyweight functionality that comes with a list. Sometimes it's actually important that we have data that we cannot mutate or change in some way. Now, the last thing that I want to cover briefly here is the fact that strings are actually collection types as well. I know I mentioned it very, very briefly when we brought up the topic of strings, but strings come with a lot of the functionality that lists do. Of course, not all of the functionality. For example, there aren't functions such as remove, insert, append, etc. But we can totally fetch items from strings. And we can do stuff like check to see if something exists in a string or get the length of a string. So we have our name string, and that is equal to Holly right now. Let's perform some basic operations. So let's say we wanted to get the first element. We could do something like print name at the index of 0. If we wanted a range of values, let's say the first 2 items, we could do from 0 until 2. Let's say we wanted to check to see if whole is in the name. What we could do is something like this. Print whole is in name. Okay, and that's a totally valid operation. Also, we can get the length of name, so we could do print len of name, and that is also fine. So all of these will return some values based on whether or not they're either true or false in this case, or the count or the specific elements. Again, we can't really call upon these higher level functions, append, insert, etc., nor can we reassign values like this. Okay, so we can't use a subscript syntax, that's what this is called, to reassign values in strings like we do with regular lists. So that is actually pretty much all we wanted to cover here. We went over tuples, how to create them, how to reassign the entire tuple to a variable. We cannot reassign individual elements, but we can certainly access them, and we can also check the length and see if a tuple contains a value. We also saw that strings are indeed collection types by talking about how to fetch an individual element, a range of elements, check to see if a substring, a smaller part of a string, exists within a string, and also to get the length of a string. So what I recommend you do is definitely practice with tuples a little bit, see what functions are available with tuples that aren't necessarily available with lists, or rather vice versa, because of course everything a tuple can do, a string can do, a list can do, but not necessarily the reverse. Play around with these functions with regards to strings, and when you're ready to move on, we'll cover our final collection type, which will be dictionaries. So stay tuned for that. Thanks for watching, and we'll see you guys in the next one. What is up, guys, and welcome to the third and final part of our collections tutorials. In the previous section we covered tuples, and before that we covered lists, so the final collection type we're going to study will be dictionaries. Let's head on over to Replit and get started. Alright, so again, moved all that code into archive. Hopefully you're comfortable with tuples and these few string operations we can perform as we're about to launch into something quite different. So dictionaries are perhaps a little bit more complex than lists and tuples because instead of storing one value per element, we're actually kind of storing two values. So within lists and tuples, all of the elements are stored at specific indexes. Within dictionaries, values are stored at keys. So for every key that we have, for every value that we actually have a key and that value. So a dictionary looks like this. We'll have dict is equal to, and then the curly brackets instead of the square or the round parentheses. Also, we specify things like this, key, colon, value, okay, and this constitutes one element in a dictionary. So technically, it's two values stuck into one. So if we want alternative values, we do this, and we just keep on going. So again, the order of these keys and values is really unimportant. What is important is the key at which each value is stored. That means that we do have to know the keys, but there are ways to check to see if keys exist, and so on and so forth. So let's go ahead and get set up a dictionary. What I'm going to do is simulate key presses and some actions that we want to perform. So I'm just going to say actions is going to be equal to my new dictionary like so. So this specific dictionary will have keys as strings and values as integers, although there's no restriction on that. We could have, for example, keys that are strings and values that are strings. We'd have keys that are strings and values that are booleans or numbers. We could have, in fact, keys that are booleans and values that are booleans. So there's endless combinations between keys and values that we can have. This specific dictionary we're going to keep fairly simple. We'll just keep the keys as strings and the values as integers. So we're simulating key presses, so I'm assuming this is the right arrow key, and we're going to store the value of 1. So when the user presses when the user presses the right key, we'll increase a value by 1. Similarly, when the user presses the left key, we want to maybe decrease the value by 1. So this could simulate moving back and forwards or just left and right. Now, just like with regular lists and tuples, we can reassign the entire dictionary if we really want. So we can say actions is equal to a brand new dictionary filled with a bunch of other keys and values. We won't do that, however. I just want to print out the actions just so that you can see what that looks like. So we'll go ahead and run it. And you can see that just like before, we get the entire thing printed out just as it would appear in the actual code there. Okay. Now we access elements based on their key. But what does that mean for our syntax when we're trying to actually access those elements? Well, it's actually pretty similar to with lists and tuples. We get the name of the dictionary in this case, we open up these square brackets beside it, but rather than putting a position such as 0 or 1, because the dictionary will assume we think this is a key, we actually put the name of the key. So in this case, let's say we want the value of 1 here. We put the key that it's stored under, in this case R, and that returns us the value. So if I were to print out actions of R, we would actually get the value stored there, which is just 1. Okay. Similarly, if I printed out L, I would get -1. Now where this gets interesting is if we try to access a value that doesn't exist. For example, let's say I try to print out actions of G. Okay, so that key is actually not specified. Just like before, this is going to give us an error if the key doesn't exist. Same with if we try to access an index within a list that doesn't exist. What we could do instead to keep things safe is if we're not sure a key exists, we can actually use the .get function. And then we can put in the key that we want. So let's say we think that the key G exists. We can go ahead and run that. But instead of this crashing the program, we get the value of none. So the value of none is similar to the value of null or nil in other languages. It just means there is literally no value associated with this. So if we try to do anything with this, it might cause a program to crash. But we saw that if we just do this on a key that doesn't exist, it definitely causes the program to crash. Now, this also makes things very interesting for when we're setting elements within a dictionary. So let's say I want to update my right element to be 2 instead of 1. What I can do is set my actions at the key of R equal to 2. Okay, and that's totally fine. And go ahead and print out my actions. And you'll see that I've now updated the value there. However, what if this key doesn't exist? What if I tried to do, for example, actions of U, so representing up, is equal to something? Maybe I want to set this equal to 1. Is this going to crash my dictionary? Well, actually, it doesn't. This is a totally valid operation. So the way that a dictionary works when we set an element is if this key does not exist, it will insert a key and assign this value. If the key does exist, it will simply assign the value, like we saw with this line here. Now, if we're ever unsure about what sort of keys or values exist within a dictionary, we can actually print out just the keys, or just the values, or perhaps combinations of both. Of course, we can print out the entire dictionary as we saw here, but let's say we're not aiming to print something, we just want to fetch the keys or the values to do some checking of our own. So what we can do is call upon actions.keys, or actions.values, or if we want all of them, we can do actions.items. In fact, might as well demonstrate one of each, and we'll go ahead and just print them out as well. So let's get those parentheses in place, just paste that and paste it there. We'll do the keys, we'll do the values, and we'll do the items. We'll go ahead and run that. Okay, and looks like I have disconnected, so this is just going to take a minute. I'm just going to pause this and wait for this to finish. Okay, there we go. So we finished. So we can see that the dict keys got from this call are R, L, and U. That makes sense because we of course inserted U here. We get the dict values, 2, -1, and 1, and then the dict items, which actually returns a list of tuples that are the key and then the value pairings. Now, because we use this methodology to insert items as well as append items to dictionaries, because again the order doesn't matter, there are no need for append or insert functions. However, there are a couple ways which we can remove items. We can call the del function, or we can call the .pop function. So the del function is going to be used to delete an item at a specific key, and actually same with a pop. So for example, we could do actions at a specific key. Let's say I wanted to remove my up action, and then I'm going to go ahead and print out my actions that remain. Okay, so if I run this, you can see that now my dictionary has removed that R, the U action. Okay, so it's moved both the key and the value associated with it. Similarly, if I did actions.pop and passed in the key, so in this case, that would be maybe I want to get rid of my right action. Okay, and then I go ahead and print out my actions. This will do basically the same thing. For all intents and purposes, it's pretty much the same, just removing that key and that value from the dictionary. The final thing I want to show you guys, although there are additional functions that you can use with dictionaries that we just won't cover here, will be the in operator. So just like before, we can determine if something exists in a dictionary. In this case, the key is what's really important, so we might determine if a key exists inside of a dictionary. So in this case, we know that L exists, so we might do something like print L in actions. Okay, this is either going to return true or false based on whether it is. It is in actions, it's actually the only one left, and so we return the value of true there. Alright, so that is pretty much all we wanted to cover here. We've gone over the main functionalities that dictionaries provide. So just to summarize, instead of the order or the index of items, it's the key that the value is associated with that's important in a dictionary. We can use the get function to safely retrieve a key, or we can just use these square brackets, and that will actually get the value associated with the key we pass in. We can also set an item or insert a key value pair by using the square parentheses again and then setting a value. And there's a few functions that we can call that exist that are common between dictionaries and lists, although these are dictionary specific, that help us to modify the dictionary or retrieve values in some way. So definitely play around with these. You'll definitely find as you develop more complex programs that dictionaries are extremely useful. Okay, so once you're ready to move on, you've had enough practice using these functions, creating and modifying and accessing dictionaries, then we'll start a brand new topic of control flow. Okay, so stay tuned for that. Thanks for watching and see you guys in the next one. Hello everyone and welcome to our tutorial on control flow. Over the next few tutorials, we'll be studying various forms of control flow in Python that allow us to implement logic in our code. We'll divide this particular section into two main subtopics. The first will be a basic introduction into control flow. This will be just a couple of slides explaining what control flow is and then talking about the kinds of control flow that we'll study here. And then the second half will be devoted to turning to Replit and going over some examples of one form of control flow in Python code. Over the next couple of sections, we'll be exploring the other forms. So for starters, what is control flow? Well, in simple terms, control flow is typically checking some sort of a condition and then executing some code if that condition is true. So like I said, this allows us to implement logic in our code. Up until this point, we've basically been executing every single line of code from top to bottom, regardless of its value. That is, of course, as long as it could run. However, in a real program or application, that's not generally what we want to do. There will be certain parts of the code executed based on certain conditions, and that's what control flow allows us to do. So some examples of these conditions that we're checking for could be: is one number equal to another? Is some number greater than or less than another number? Or perhaps does a list contain a specific value? These are just a few of the examples of which we would apply control flow to execute certain parts of the code. So we'll study three main forms of control flow. The first will be basic if statements. We can also go into the variants such as the else if and else statements. We'll take a look at while loops, and then the companion for in loops. Because each of these topics is going to be a bit more complex than what we've been studying up until this point, we're going to devote a separate section to each. On this one, we're going to be focusing just on if statements. So without further ado, let's turn to REPL.it and get started. Alright, so here we are in main.py. Again, I've cleared out the code and stuck it in archive.py. The last section we covered was the dictionaries section. So make sure that you are comfortable with everything up until this point, as we will be incorporating at least some sort of collections in our upcoming tutorials. Okay, so getting back to control flow. So we're going to focus on the basic if statement first, and then we can dive into its variants. An if statement is a simple form of control flow and is just used to execute some code if a condition is true. So it looks a little like this in Python. If some condition is equal to true, then we execute some code. Okay, so this is pseudocode, by the way. This isn't real Python code, hence why there are errors in here. There's a couple things to note. The first is that this is some sort of a test that has to return true or false. Okay, so we could stick in a Boolean value there. This could be, again, comparing different variable values, seeing if something exists or not, so on and so forth, as long as it returns true or false. If it returns true, then we execute this code here, whatever it could be. It could be multiple statements long. It could be running the entire program if something evaluates to true. But just know that this code will execute only if this is true. If this returns false, then we ignore all of this code here. Now, if you're coming from other programming languages, you may be very familiar with the curly bracket syntax. Python doesn't really use curly brackets. Instead, the indentation is what is important. So if you note, when I actually went to write that code and I press enter or return, you can see that it automatically indents here. Okay, so the indentation is very important. And if I want to write multiple statements inside of my if statement, they have to all have the same indentation. As soon as I forgo that indentation, this is no longer part of the if statement. Also, some other programming languages need brackets or parentheses like this. Really not necessary in Python. In fact, you shouldn't add those parentheses in. So let's take a look at a very basic example, and we'll simulate something like a key press. So I'm just going to say something like key is equal to R for write. Realistically, we would use some sort of a library to detect which key has been pressed, but let's just pretend that this is a way to represent which key has been pressed. Okay, so let's say if the right key is pressed, we simply want to print a statement, and if any other key is pressed, we're just going to print either something else or ignore things. So let's say we want to print something like move right if the right key is pressed. Well, if I just run this, then it's going to print this regardless of what key is pressed. If it's a left key, it's still going to say move right, which is not really what we want. So what we want to do is open up an if statement and say something like if key is equal to right, okay? And if it is, then we're going to print move right. Okay, so basically here we're just testing to see if the value stored in key is the same as this value here. So we use the double equals when we're comparing things. That's actually something we covered in the operator. This is assignment, this is a comparison. Okay, so if these two values are equal, then we'll execute this code. Let's test to see if it works, and indeed we execute that. As soon as this value changes to something like left, then we get no code being executed because there's no code following this. Of course, if I added another print statement down here, let's just say something like done, that will run regardless of whether this is equal to true or not. Okay, because this is not part of the if statement, it doesn't have the same indentation. Okay, now realistically, the game is probably going to have multiple actions for multiple different keys. For example, we might want to move left if the left key is pressed. So perhaps we should add an additional check here. Rather than just do another if statement, we're actually going to use an elif statement, which is short for else if. Okay, so this adds an additional check if this one fails. So let's just simulate this. Let's say if we want the left key, or if the left key is pressed, we're just going to do left here. Okay, then we're going to print move left instead. So this test is only performed if this test returns false. If this test returns true, we execute the code and we ignore the rest. If this returns false, if this returns false, then we ignore this and we perform this check. If this returns true, then we print the statement. So for example, if I run this now, you'll see that only move right is printed. If I change this to left, then, oops, place the wrong thing there. If I change this to left, then you'll see that move left is run and this statement is not. If this is something else, okay, then you'll see that only the done print statement is run because both of these checks returned false. Now there's one final part to this kind of combination here, and that is the else statement, like this. So what the else statement allows us to do is execute some sort of default code if all of the above tests fail. So we can think of this as being a fail-safe. Realistically, there will be lots of other keys that could be pressed, and perhaps we want to let the user know that that was an incorrect key or something that's not recognized. So for that, we could just say something like print here. We could just say something like invalid key. Okay. So now if we run this, you'll see that this fails, it returns false, so we ignore this. This also returns false, so we ignore this. And then the else is actually not performing a check. It's just saying if everything else fails, we still want to do something, so we're just going to print invalid key. Similarly, if any of the above tests pass, then we ignore both the elif and the else statements. Alright, so those are the basics of the if, elif, and else statements. Now you can add whatever combinations and other logic that you want in here. For example, you could just have the if and the else statement. That's totally fine. You could have the if and elif without the else. You could have just the if statement. You can also do stuff like nest if statements. You can have an if statement inside of an if statement. You can also use the logical operators and an or to add additional test cases to your conditions, just as long as your conditions return true or false in the end. Also, in this case, we only really worked with strings and equals. You can absolutely use any sort of operators you want, any sort of conditional or logical testing operators. You can also work with numbers or booleans or floats. Really is up to you what sort of variables you want to use in your tests. As per usual, the best way to learn concepts like this is definitely going to be to practice. So try to model some scenarios where logic will be involved. That means you execute some part of the code if some condition is true, and another part of the code if some condition is false. Again, you can make these as complex or as long as you want them to be, with many, many else-if statements if you need to. So have some fun with that. Try to incorporate your AND and the OR operators. Try some nested if statements.